Hi everyone, we are from group D1213. Today, we would like to discuss about our self-designed infix expression. Before we start, I would like to introduce myself first. My name is Yong Zhong Yen, and my teammate is Terence Lim Jun Jae, Joshua Tan Hong Liang, and Tan Kai Feng. This is our group infix expression, which is x equal to bracket a plus b multiply c bracket subtract bracket d divide e subtract f bracket plus g. So in this part, it required us to convert it from the infix expression to the postfix notation. So before we convert it into the postfix notation, let's analyze this expression first. In this expression, we can find that there are bracket, plus, multiply, subtract, and divide. According to the mathematical logic, a bracket has the highest priority first, and the next goes to the multiply and the divide. And the last one is the plus and subtract. So in this expression, there are two brackets. So we will start to convert it from the back of the expression. Now we look at this bracket first. In this bracket, there are divide and subtract. So we will start to convert it in the front part, which contains the divide first. Now we have to find the first operand first, which is D, and the second operand is E. And the operator is a divide. Remember, an operator will shift to the back of the second operand. So in this case, this divide will shift to back of the E. So it will become D, E, divide. So the next step, the DE divide already counted as the first operand. And now the second operand is F. And the operator is subtract. So the operator will shift to the back of the second operand, which will become a D, E, divide, F, subtract. And now we have done to convert all the operand in this bracket. Now we will go to the front part of the bracket instead. Now, let's look at this bracket first. This bracket contains a plus and a multiply. So we will start to convert it from the part of multiply first. The first operand is B, and the second operand is C. The operator is multiply. So as I mentioned just now, an operator will shift to the back of the second operand. So it will become B, C, multiply. It will become like this. And the next step is we will convert the A and the BC multiply. And now the A is the first operand, and the BC multiply is counted as the second operand. Now, the operator, which is the plus, will convert to the back of the BC multiply. So it will become A, B, C multiply plus. So it will become like this. So after we have convert all the operand in the bracket, we can remove the bracket. So it will become like this. Now we have left a subtract and a plus G, which we haven't convert it. So now we have to start to convert from the back of the expression. Now we will convert plus G. So the operator will shift to the back of the operand. So it will become A, B, C multiply plus subtract D, E, divide F, subtract G plus. And now we only left the subtract. So if we will shift it to the back of the operand, as the first operand now is A, B, C multiply plus, and the second operand is D, E, divide F, subtract G plus. And this is the operator. So the operator will shift to the back of the second operand. And now the expression will become A, B, C multiply plus D, E divide F subtract G plus subtract. Now this is the complete expression of infix expression to the postfix notation. Next step required us to find the zero address machine instruction. To find a zero address machine instruction, we can refer back to the final result we have got from the postfix notation just now. So as we can see, the first instruction is A. So we can just put the word push A to represent we have put a A in the accumulator already. And the next word is B. So we can just put push B. And the next one is C. We can put a push C. And for the next one, we have a multiply. For the operator, we don't have to put the word push to represent its instruction. Instead, we can just specify it by the opcode. So we can just put MUL to represent multiply. For the next one, we have a plus. For plus, we can just put the opcode add to represent its instruction. For the next step, we have a D. So we can just put the word push D. For the next one, we have a E. So we can just put the word push E. For divide, we can also use the opcode to specify it. So for the next instruction, we got a F. So for F, we have to push F. So after F, we have a subtract. So we just use the opcode to represent it. After subtract, we got a G. So we just put a push G. After G, we have a add. So we just put its opcode. After add, we have a subtract also. And we also just put its opcode as well. After we have done all the instruction, we have to put a pop X. It represents all the instructions is stored and is a part of the X.
Hi everyone, my name is Terence. Today I would like to show you how to draw stack diagram. So for the first instruction, push A. Push A in the stack diagram, you just write an A like this at here, okay? And then next instruction is push B. Push B, you write the B above the A like this. And then another step is push C. For push C, you just write the B above. You just write at the B above, okay, like this. The C above the B. And then another one is multiply. Multiply, just take the above one to down. Because the stack diagram is see from above to down. So it's like this. B multiplied C. So it's like this. Okay, and then the next is add. Add, you take the above one to down. Like A plus B multiply C. And then another instruction is push D. Push D, that means you write the D above A plus B multiply C. Like this. And then another step is push E. Push E, you write the E above the D, like this, okay? And then the next instruction is divided. For divided, you just take the above one to down, so that means like this, D divided by E. And then another instruction is push F. Push F, you just write the F above D divided by E, like this. And then subtract. You take the above one to down, that means D divided by E, subtract F. Subtract, that means minus also lah. push G. Push G, you just write the G above D divided by E subtract F, like this. And then another instruction is add. Add, you just take the above one to down, so it's like this, D divided by E subtract F plus G. And then another one is pop, subtract. So A plus B multiply C subtract D divided E subtract F plus G. Take the above one to down, but is the whole expression, the whole thing to down. So it will form like this, A plus B multiply C. And then last instruction is pop X. When you see pop X, that means the serial address is N, and also for your stack diagram. So it will form like this, X equals to the whole thing for the previous step. Thank you for watching the video.